Hello class, this is a video tutorial on the extension Trig Identities. In this video we're going to be looking at how we can apply these identities to different questions. And I'll go through very quickly these identities here and what it means. So here we have the sum a plus b or difference a minus b of sine, cos, or tan. I need to draw your attention very closely to the different symbols here, because one of them has minus plus, two of them have minus plus. So if we have sine A plus B, so we're looking at plus, it becomes sine A cos B plus cos A sine B. If we had sine A minus B, it becomes sine A cos B minus cos A sine B. Likewise, for cosine, if we had cos A plus B, it becomes cos A cos B minus sine A minus B. Notice how they are both on top. If we had cos of A minus B, it becomes cos A cos B plus sine A sine B. I think you get the idea. It's the same for tan. If we're looking at the plus, the denominator has a minus. If we had a minus, so tan of A minus B, the denominator becomes a plus. Now we could go along and just go through each of these in depth, but it's best if we just demonstrate how we might use these. So let's go straight into it, and here we go. Oh, by the way, if you want to see proofs for this, you can check it out on the other video. But you'll see that we're able to solve these questions without the proof. So let's get straight to it. So sine of A minus B. So we're looking at sine of A minus B. Very simple. That becomes sine of A, the first term here, cos B. Since we're looking at the minus, we take the minus on the denominator, minus cos A sine B. That's pretty much it. We can't go any further than that. Just simply expanded it, and that's it. No problem. Now for this one, slightly more tricky. Let's take a look at it again. Instead of it being A, well, A becomes 2 theta, and B becomes little a. So we're going to look at this identity here. So it becomes, let's use a different color so not to mix it up with the previous. So cos A is 2 theta, so it becomes cos 2 theta, and B becomes this one here, so it becomes cos A. Since we have minus, it becomes the plus that we're looking at, so plus sine A, which is sine 2 theta, sine B, which is that little a there. Now we could stop here, but now that we have this double angle, we're going to now apply our double angle identities. So let's keep going from here. Cos of 2 theta becomes cos squared A minus sine squared A. So this becomes cos squared theta minus sine squared theta. Since we have the A still there, the cos A, we're going to multiply that by cos A. Likewise, sine 2 theta, that's this identity here. So this is going to be plus 2 sine theta cos theta outside of sine A. Now from here, let's see if we can go any further. Let's move this down a little bit more. Whoops. We can expand this one here. Cos A, cos squared theta minus, no, actually, let me take that back. Expanding it's not going to help because it's making it more complicated. I think I'll leave it there. I think it's enough that I demonstrated the expansion of sine 2a and cos 2a, as well as the sum or difference of these angles. So let's leave it at this for now, and I'll leave it to you in order to simplify this further if it's possible. Okay, so let's move on. Whoops. Here we go. So for this, we have tan of 45. So we're now looking at tan. So tan of A and B. So it becomes tan 45 plus tan B, which is 7y, all over 1. Since this is plus, since this is a plus, if you take a close look, if tan is the sum plus, we take the minus instead. So 1 minus tan 45 tan 7y. Now from here we can simplify a little bit further, because tan 45 degrees is 1. So 1 plus tan 7y is just tan 7y. It's going to be 1. This is going to be minus, so 1 minus tan 45 is 1 times tan 7y. So this is now 1 times tan 7y. That's just tan 7y. And that there is as simple as I'd like to keep it for this example. I hope that makes sense to you. Let's move on to one last example shown here. This is actually nearly identical to this, except instead of minus, it's plus. So we're going to now have it as, we're going to be using this one once again. This is A, and that's B. So it's going to be cos 2 theta, cos A. Now, since it's plus, we take the minus instead. So minus sine 2 theta sine A. From here, once again, we can expand this double angle, cos 2 theta. This becomes, looking at this one, this becomes cos squared theta minus sine squared theta cos A, which is still here, minus sine 2 theta becomes that identity, so that would becomes 2 sine theta cos theta sine A. And as before, I'll just leave it at that, and I'll let you try and expand and simplify this any further. So I hope that gave you an insight into just the simple application of these identities for certain examples. Hope to see you in the next video, where we go through a few more examples of where these might be applied. Hope to see you then. Best of luck.